making sure I have caption. Screen share. Let's move this. Okay, so I will work on updating your grades. I meant to do some of that today, and then I got caught up fixing things and helping. And anyway, help if I switch to the right screen. Okay, so we're gonna go over Unit 5 notes and our assignments for today. We'll talk about defense in depth and a little bit of infrastructure control. Our lab today is gonna focus on using some of the tools to analyze web application because almost all applications in the organizations are web app. Because it's convenient and it's portable and but with that we would look at the controls and the security. We're also going to do a honeypot section at the end. So in the case if you want to use it to see the type of attacks or things that would jeopardize your network or your systems, you can understand how to use these tools. Okay, so defense in depth is a way that we would layer our security controls and approach. In security solutions, we don't just have one type of solution. We want to integrate overlapping solutions. That way we will have a more thorough control. So that means that we have to come with the layered approach in organization. So in the prior class or in your current class now, you probably have learned technical control. We have a lot of say in this area from cybersecurity and the IT. And then administrative control, a lot of that comes from business operation requirements. And the internal policy for the organization, the practices for to be able to have the business. And then also the regulation requirement that you see, rules and regulation, depending on where you operate, some nation or continent would demand a certain type of agreement or rules, and then others, right? Some are more flexible than others. So for United States, we would say state, right, and federal government, that's gonna really mandate a lot of our technical and administrative control. And then the physical control that comes down to your building, your physical systems, your physical ports. And some of that fall in between both administrative and technical control. And then we want to have detection, prevention, and also corrective. So detection and correction is really, they both fall under reactive type of security management approach. So your alarm system, right? Or even surveillance system would probably fall under detection, where correction is really responding to the type of security events that you have, possibly attack or leaks. So with that, we would see the layered security approach. That means that we would assess the gaps. So as an analyst, you have to really look at the type of holes or gaps that you're working with, determining how you're going to be able to reduce the risk through reducing the potential threats or the current threats that you have in the system and in your organization. So your data security is one of the important area, because data, it can be quantified to the dollars, and data is asset. So we want to make sure that data is protected, and that could be sensitive data, confidential data, or even in some cases, public data that could mean something else to another entity. So we need to make sure that we have data security and policy in place. That means that you have to classify your data, meaning ranking your data based on its importance, and be able to control how the data is accessed based on its importance. And then implementing protection for your data, whether we would use encryption, we would be able to back up our data, making sure that we have redundancy in storage for our data, and then permission control for the data. So this diagram kind of shows that data is really the central focus in the layered security area. Then working outwards, we're going to use application security because the application actually access the data as sources, right? Does that make sense? So when I'm using Microsoft Office, right, I use that to generate data, to create documents, to create Excel spreadsheet, etc. So the data is really the core, and then the outside of that is your application. And to use the application, you would have endpoint system, your desktop or your workstation, your laptop, right? Also could be mobile devices. And then all of those are interconnected. So we have network security on the outside of that, right? And then with that, we want to protect the network. So we would have parameter or perimeter security. So here, we can answer the first question for our assignment. And this is chapter 7. So we want to describe the type of controls that we're going to be working with for defense in depth. And this is going to entail layered strategy. So the first area is your technical control. And we should have learned this from 25, 27, and other classes. The technical control for IT and cybersecurity team or security team means that we can configure the rules of security appliances or system to detect and prevent internal and external threats. So internally, we got to make sure that we can detect and block any attempts in accessing sensitive data. So that means that we can configure permissions, right? Or even privileges to a certain application. So it's not just security appliances, but we can also that would entail servers and systems. So you can add. But in the area of security appliances, we can set up firewall rules, like application firewalls, host-based firewall, that, in the case if we want to do NIDS, right, network intrusion detection, and then IPS, intrusion prevention system. And intrusion prevention system allows us to formalize the process and control of external threats, meaning that we can block entity that would want to have unauthorized access to the data. But in the IDS, right, internally, a lot of companies would use IDS, intrusion detection system, to identify internal threats. And in the case where external threats infiltrates the system or the network, they would be able to use NIDS, right? And we learned in CIS27 that NIDS, network intrusion detection system, does not prevent. It only sounds off the alarm when threat occurs, or there's existence of threats. The administrative control really is for business operations. So we can say that we would create and apply organizational rules or policy. We would provide regular training in security awareness and practices, because without knowledge and education, people would not know what to do, right? In my 27B this week, we're going to talk about insider threats, and it's really going to focus a lot more in how we would do better in administrative control. So the organization might have a set of rules already in existence. You need to revisit it and really think about how those rules are effective or not, right? Having a discussion with the business department and operational units to really understand whether those controls are effective. And if they are, you simply would apply, right, the rules. It reinforce the rules, really. So in the case where people are sharing passwords, what kind of reinforcement do we have for that, right? Do we dismiss the employee? Do we, have them have corrective actions, meaning that we would write them up and then we would send them through training and so on? Because the users and the entity in the network or even our partners, they would not apply, right, the practices unless you have some consequences in the violation of policy. So administrative control is also very important. And then you have physical control. A lot of this comes down to the physical system, buildings, facilities, right? Branches. So we would use logs, barricades, surveillance like camera system to detect, deter, and prevent physical harm. And sometimes security guards, a lot of companies, you see that, right, to really protect their assets. So the physical assets, equipment, those things need to have physical protection. And in the case of like your workstation, simply putting, zip tying them down, bolting them down to the desk. So that way someone cannot walk out with an actual system is important, right? Simple things like zip tying the cables sometimes can deter or even slow down the process of someone taking the system. For laptops and other equipments, you can have logical and physical control in that. In the case if they leave the laptop at a coffee shop, right, we can logically lock that laptop. So just like how you lose your iPhone, you can use Apple service to lock your account so people don't access your account. And then sometimes they would provide like laptop cable locks where, if they use it with a certain desk, they can actually lock it so that way it will be a little more difficult for someone to walk away with it. But I feel like those cable locks is not very effective in that you can cut them, right? Large cable cutters can do a lot then too. And then in the network environment, you have to look at cabling is important. Cooling system is important for the building. So if you have heat, that could jeopardize your system. So you have to have proper cooling, ventilation. You have to have backup power for physical control. There are many things that goes into that, especially in the area of IT, outside of just door locks, right? Or barbed wire or lighting, fire suppression, things like that. And in our case for California, I think, building codes helps us in the physical control in that we have earthquake, right? Implementation, but in the case if you have racks and things, you got to make sure it's earthquake proof, right? Racks don't fall down in the case of earthquake, because if racks contains your system and appliances, so if it's destroyed, your network is destroyed. Any question regarding controls? And then based on the diagram, we can say for our security model, we would start with the center, which is your data security. So a way that we can implement control for data is we would use data encryption. Depending on whether your data is at rest, that means that it's stored or archived, or when your data is on the move, where it is transmitted, being sent or downloaded and uploaded on a certain site. So we would use stream-based encryption for web, and we can potentially use different type of algorithm or encryption type to control our data access or protect our data. And with that, we would also look at data classification. Another example is you can also set permissions for your files, right? I'll add that. You don't have to, but you can say permission for files and folders. So in the case if you have a network drive and you want the users to be able to, for example, like if you use OneDrive at school, right? You can attach a document into an email. You can share that document via a network drive based on given share permission, just like how you use your Google Drive. So we can look at the type of permissions, and with that, we need to do permission audits for your files and folders. So those are objects or even drives, right? Sometimes you would also encrypt USB drive for data control or data security. There's a lot going into data. We have to think about like how it's used, where is it used, where is it located, who is using it, who should be using it. So when you classify the data, right, if you have confidential data, you would have the proper group that, and you would set up the permission for those groups to be accessing that class of data. Where you have public data, you would allow all to read the data, right? Sometimes we might not want the data to be downloaded and reshared, so we would allow public view of data. So it really, you have to think about like how the data is used. Who should be using it? Where is it located? And who should have access to it? Okay, and then application security. For the application itself, the most important area is we want to look at input validation. Okay, meaning that we want to reduce injection. So in an application where the user can log in, type in their username and password, we would want to input validate. I know that some of you took programming classes, right? I always harp about input validation to really help the performance of the application, but we also want to input validate to control injection, like SQL injection, because almost all application is tied to a database. So whenever that you have user input, you don't want the user input to be stored into the system memory. You want the user input to be stored into a table where, you know, because you might have thousands and millions of users. So you want to have a database connected to that application. So each user can have their own input and it's stored on a certain record on that table, and you can use relationship to do a relational table to draw the data when the users needs the data. Or sometimes you might have non-relational database. Whichever it is, if you have massive data, database is required. And with that comes injection attack. So if we input validate, we would reduce the risk of injection. It doesn't mean that they can't do it, right? But we can set up rules in the input validation to prevent certain type of query-based characters. You know, so this is why sometimes you cannot use a certain character in your passwords, right? Let's say that you like using equal sign in your password, but it doesn't let you because they input validate. We can also input validate based on the number of characters that you can fill out. So for example, like an online form, right? They want the customer to have feedback, and you know, maximum limit is 255 characters for that box to input, right? And we can check for the characters. So developer actually, for web development, they have to look at how they would be able to input validate and make sure that when they are submitting that string, it's not an injection string, right? Because simply find a way, a box, a fillable form to be able to inject, that's typical. Endpoints, we talk about that. So for endpoint system security, we can do an anti-theft. We can also do security software to prevent malware. So we can automate this process. And then network security, we touch on using security appliances, but having security appliances, meaning you have to configure security appliances to have the proper policy. We can also make sure that we have the proper load balancing to block unwanted traffic and have performance. And then unauthorized access. So we need to control system privileges and prioritizing our network traffic. So you can set up static routes for priority, sensitive type of traffic, or you can load balance that, right, for quality of service. And then for perimeter, we can do fence, barricades, security guards, fire suppression, on and on, okay? So normally when, for the upper division classes, when they have to write a complete security plan for me, I normally tell them that you need to have multiple, at least 3 things in each area, right? So at least 3. So you can't just have one, like, oh, input validation for application, that's not enough. Okay. So you have to think about like your web server and your application server, how is it configured? So you have to encompass, or you have to overlay technical and administrative, and so your physical is in for each component. Okay. So out of the box, a lot of the times company buy security plans, and the people who create those security plans and solutions, right? And then some of this will break down to things like what kind of software you're going to use, how do you configure that type of software, and so on. Bless you. So that just slowing down potential threats, right? It doesn't mean that it won't happen. It just reduces the risk. Okay. Any question regarding layered approach? Okay, next. We're going to talk about zero trust. So zero trust means that we're going to remove the trust that's used to be placed on the system services, individuals inside security boundaries. So when you have domains, in order to establish communication, the system has to trust another system in order to, replicate or send data or submit data. Okay. So we have to take a look at the type of trust that exists on the systems and the services that's tied to that trust. When you authenticate, like for example, on a secured website, right? You establish the session ID. So during that period of time, the two systems acknowledge one another. And in order to establish service, those systems create a trusted environment. Okay. So in security, we have to look at that the saved information, the established trust needs to be evaluated and checked, because there should not be a trusted environment prehistoric, right? So we want to make sure that we check these things, because the deeply layered security model, the individual devices accounts are part of the security design. So we need to really think about how those trusts was established, and if we remove them, how are they going to be reestablished? Okay. So this is why when you exit the page, let's say I logged in, right? And I close out the page. When I reload that page, it should not resave my session ID. Okay. So we have to question like the cookies, the session that's established, because someone can capture that session ID and revert back to the page where I actually logged in and accessed my account. So if we establish a zero trust environment, what we can do is we don't revert back to that session ID. We have to question how the system is saving the information where someone, an unauthorized entity, can access that type of information. Okay? So because we use such a blended environment, we have to make sure that we manage, monitor, and assess how each process is generated for a specific technology. Smart devices compared to your servers, right? So this is why security demands such a vast amount of knowledge across the technologies, and they are always changing. So it's important to keep up. Okay. On the next part, we're gonna talk about a jump box. So the purpose of the jump box is in the organization for security purposes. It's used to access and manage devices that are in different security zones. For example, your web-facing zone, your DMZ, demilitarized zone, right? It is different than your internal private network. So in order to manage and control these devices like your web server or your database or your email server for the public front, like your customer, we would use a thing called the jump box. And to manage it, as the specialist, the technician, or the administrator, they would connect to the jump boxes using VPNs or virtual private network, and that would allow us to have secure connection to those systems. And potentially someone can scan you as you connect to the system because they understand that these jump boxes are controlling, right, the configuration of the other devices. So they would monitor the traffic and possibly impersonate you. So you want to make sure that your connection, your remote access to those systems are private. Any questions? So the story goes that, IT likes to use a box to control another box or one box to control many boxes, right? But that's typical because we want to centralize the management aspect. So if you have 4,000 devices, maybe I have a jump box to control my smartphones that I give out to my employees. And then I would have multiple boxes to control, the laptops or the tablets and so on, right? So basically it's just another system that you would use to control the devices that you have to manage in different zones. So, I might have a wireless segment that I want to be able to have a jump box for that. So the DMZ area is essential because it is public facing. So we have a different set of security rules that are set for those type of systems where the public still be able to access, the information that they need on those systems, but we also want to control some of the private sensitive information that's coming from that system that's being transferred to the private network for operation. So for example, right, like nowadays you can buy a car from online. Okay, you just create an account with a certain company that sells it. So you have to access the website. You fill out the information. That information goes into a database and those systems sits on the DMZ. But then, when it comes down to your social security number for loan application and such for that car, it would then transfer to the private network and be stored, right, in a database and for the customer purposes for loans. and your loan will be processed, and some of that information is going to be very sensitive to the customer, right? You have to protect that data. So with that, we have to control how the resources used, encryption is used coming from the DMZ network into the private network, and so on. Any question? Okay. So a thing that we normally revert to, I think the understanding networking is, again, I'm going to say this many times, very important. Like cybersecurity is like 80% networking. So, but we can also use network segmentation and also physical or system isolation to allow us to control the security part of our system. So the physical segmentation, we can have separate network by segmenting, by cabling, by connecting the network a certain way. So for example, if I have a wireless segment, right? That wireless segment is going to be physically connect. My wireless router is going to be, or access point, I should say, access point connecting to a certain switch on a physical port. I can also use VLAN, which I can logically segment that using separate IP addresses, okay? And so that way we would have both. We would have physical segmentation, we would have logical segmentation, and we can also isolate that port so that way it is not, so someone enter through that port, they would not be able to access by using what? We can do port filter or MAC filter. We can even set up firewall rules for that, right? So you would want physical and virtual segmentation in your solution for a simple thing like setting up wireless segment for your network, okay? And so, and we can also do network segmentation for departments or areas that should not intervene as far as data access. For example, right, the staff here have access to student records, grades for all the students. And we can segment the staff network different from the student network because you don't want another student to go in and look at your record, right? We control that through permission, but we can also make sure that the entity that doesn't have access to that does not connect. Because when you make things available, they're going to look. Okay, so you have to make sure that things are virtually and physically not available for the entity that shouldn't look. Okay. So the benefits of this is to reduce your attack surface and also to limit the scope and making sure that we meet compliance requirement. So that means that when we reduce the scope, we reduce the impact. They are directly correlated. And also you would increase efficiency on your network, right? Taking off the ones that don't have access, reducing the bandwidth used from those systems. Okay. And here is some diagram to show you how you can set, how this is seen from a networking standpoint for VPN. So you do have firewall for your DMZ area, right? But your firewall also needs to check like how it should pass the traffic to, you know, the jump boxes or different type of servers. So if you want to get to the VPN server and then from your VPN server to your jump box. Okay, or your VPN server to your private network. And all of that, this simply is what? Configurations on your security appliances here and here. And then making sure that you have the proper setup for your network configuration. Okay, so before we answer the next one, we can talk about physical network architecture. So I mentioned that cabling, routing, switches, and devices are important. Now, the job of the IDS is to raise alarm and the IPS is gonna block. So deny or allow, right? Sometimes you would see an all-in-one appliance, but a lot of times if they are separate, they don't interfere, right? The IDS doesn't do the job of the IPS, so it does not block. And the IPS, right, it would block based on the rules that you tell it. So software-defined network is a programmable network. We often use this for automation purposes. We can also use it to control things centrally. And we simply implement APIs or script to do that. And we need to implement or use encryption within SDN. The risk is going to lie in that if you have different vendors or multiple vendors, you do have different paths and you have to control all those paths. So to implement SDN in your infrastructure, you should use it to centralize your control through the integration of APIs. So APIs are simply what? Application programmable interface. It is a small program that talks to the main program, right? Or I shouldn't say small, just a program that would communicate with another program. So for example, right, I would use security tools are APIs, and I can use it to monitor my network, which my network appliances or security appliances already have its own application. So I can integrate the tool into my security appliance that runs an OS, right? It already has the software, or potentially it has its own tool that can be adaptable to the API. So simply adding that on top of it, or install it on top of the OS for that security appliance system. And that's going to help you monitor, detect, prevent, or even automate some of the process. And nowadays, especially with cloud, this becomes more of an essential element. So therefore, you need to learn scripting and security. You need to learn programming. Okay. And then in the case of AI, that's also very important that you need to learn scripting and, you know, and it doesn't hurt to also learn data analysis or, data analytics. There are tons of free courses that you can take, or you can take a credit course. Any question? So we have many ways to really build out the environment that we need for the business. In our infrastructure, it doesn't just entail, right, your servers, your workstations, your mobile devices, but it also entails cloud environment along with virtualized environment. Sometimes the virtual instance is in the cloud, which is, your vendor server, physical server that you use, or you lease those servers for your applications, your networking systems, etc. So VDI can be used to virtualize your desktop. So I can use Hyper-V whenever that you use your guest virtualize, like today for your Kali Linux, right? You virtualize a desktop environment as a guest OS. But on the cloud, you can see that you can have an instance like your Windows server. We saw a little bit of that through the extra credit last week instead of our lab. we can also integrate VDI for security appliances purposes. So for example, I might just use a virtualized environment for a certain type of security, like a Cisco security appliance. Okay. And with that, we would use containerization. That could be in a Docker format, or it could just be in some virtualized type of product, like VMware. Okay. So Microsoft integrated Hyper-V for virtualization. So in a desktop environment, it's pretty cool, right? You can have Windows desktop, and you don't have to install it on all the system. You can run it as an instance. And from the server standpoint, it would be able, you can pause that desktop and, update that desktop and customize that desktop to specific needs for the department use, right? Like finance desktop might be different than marketing, might be different than manufacturing, and so on. And it would save money in the long run. But in the environment like this, you're gonna see that the majority of the funds or the money is gonna go into software. And you need to patch your software, because if it's software oriented, if you don't update, right, your software, then you would run into security issues, because no software is perfect. So here it talks about virtualization, and you guys use it all the time. So using a software to run virtual computers, right, on the underlying real hardware. So you don't have to buy 10 servers. You can virtualize 10 server on one physical server. You can run desktop OS and security appliances. You can do a lot of different things. So containerization, while a lot of the IT classes doesn't, unless you go into cloud-based classes, you don't hear, I tried to get Docker stuff to work for you guys before, but as you know, if you don't use a proprietary product, if you use free product, you have to jump through hoops to get through to the free products, or the free products is, they work, but not to some extent, right? You have to do a lot of fixes for them to work. Kubernetes is very popular in the industry. So if you get a chance to, take a free course on it or a low cost course on it, I encourage you to, because this is what the industry is using. Okay. It's also used for imaging purposes, so that way you can test. It's a perfect test environment, is virtualization and containerization. So that way you can have a certain virtual environment in your container to test malware, software, to, break down your code, to all kinds of things that you can do. But you can also use it to monitor and audit. Then if you use function-based, we talked about FAAS last week, right? This is serverless, so it is definitely great in the case that if you just need to execute tasks or automate tasks. So example for this is AWS Lambda, Google Apps Engine, Azure Functions. There are more, right? But these are some of the main ones that you see in the market, because those are the giants in cloud. So some virtual environment, this is good to make notes of, is not known to monitoring tools, right? It might see it, but it sees it as a system. Sometimes it doesn't see it. So, and, you have to look at, both sides, right? We would be able to test it, but then on the other side, the attacker, if, or inside the threat, if they use a virtual environment, it might not be detected. So you got to make sure that this is regularly controlled. And then you need to do inventory of your physical, your software, and your overall system, even the virtual system. So let me move number 5 down. So how should the organization secure containers such as Docker or Kubernetes, right? You need to look at your access rights. So manage containers, access rights. A lot of these have security tools or features that you can use, but identity control is so important, like how a user can authenticate and have a certain type of, and be authorized to a certain container. So access rights. And then with that, within the container, usually they would use the container for a certain intention, right? The intention is, let's say, to test malware. So we would make sure that they have proper access and we monitor it. And then sometimes that could be a service-based type of container. So sometimes I can use the developer can use a container to build out certain type of plugins for a certain application or build out an application. And through the application, if it is web-based, yeah, it's gonna have services. All application requires certain type of service. Okay. So that means that we need to make sure that we monitor and we patch the application. Okay. I'm talking about the application for that container and the OS. And then you need to perform audits. So what do I mean when I say audit? Audit is a review process. So you have to go and review your Docker inventory, your users to the Dockers, right? Or Kubernetes, and the type of objects that they access, right? So access auditing, user auditing, account auditing, system auditing, container auditing. So reviewing all of that information, checking, right? Verifying, making sure, okay? So as an analyst, you're gonna work with lists. So we would have lists of containers, lists of rights to those containers, lists of users that have access to those containers, permissions lists, right? So the user account, within that list, you would have the user accounts, their permissions, their group's permissions. Any question? Okay, so for assets and change management, I think we talked about configure management and change management in CIS 25, a little bit in CIS 27, right? Because that's the nature of IT and security. With IT, we configure, and when we configure, right, we change the state of system. So you have to do configuration management and change management. So for us, systems are assets, right? People are assets, data are assets. But in the physical systems, we can use that as an example so it's easy to visualize. So you need to have asset tags. Those could be the sticker in the back. If you look in the back of your monitor, right? Those are there's sticker to show there's a scanned base type of number, your UPC or whatever, right? And RCCD use that for anything that's above $500, and that's a common practice, to manage it as an asset. So when the monitor or your whole desktop arrives, right? Your workstation arrives at the warehouse, they put the sticker on top, they scan it, it gets added to the inventory. So when you do assets inventory audit, guess what happened? You look at which is which, right? Is this sticker matching this system? Okay, it might sound boring, but that controls theft, right? To protect your assets. And then, based on that, then you look at how it's used, which department, the location. So they have a list of where all of these equipment exists. Okay. So asset tagging allows you to track, because one day you might retire the system, right? Or there's damage to that system. So that allows you to track, where is that system, who uses that system, right? What type of system it is. So it's good for support and maintenance, and it deters theft. In my opinion, yes, to a certain extent. You know, so asset management tool and processes, I put the link all here for you. So in the industry, we already have tools for you to use. So you just have to refer to the guidelines for the specific set. Okay. So for asset management, it is beneficial to do tagging because it simplifies the way that we identify the system, right? Basically, we identify that system by the number or the tags that's used. And we use that for support, maintenance, and theft protection purposes. So if I know that system number 4002568BC12, for example, needs to replace drives, right? SSD, then I can make sure that I use the asset tag and update the information. In a data center, this is crucial, right? If you watch some of the documentary on social media data center like Facebook, I think it's still floating around. How long does it take for a technician to replace a drive on a server? They house their own data center, right? Even though I think it's contracted, but they manage it. So normally they have 4 to 6 minutes to do a hot swap. So they have these drives set up ready with the proper tag, asset tag. So when they pull a drive, they scan the new drive and then they plug the new drive in, plug the cable in, restart the system, seamless, right? So within that 4-6 minutes, the backup server somewhere else pick up that service. So for example, you happen to upload a video to Instagram or a picture to Instagram during that 4-6 minutes, right? Is there going to be a bog down? You might see it, you might not, right? If they have enough servers, that's going to be the failover server is going to kick in. So, and then it's going to pick back up and that server is back up online and we're good. We're in business. So it's less than, normally they say it's less than 6 minutes just to hot swap. So that means that, the time that you read the notification on the ticket message, your system is going to automate it. It's going to say, hey, I'm failing. Come and get me, right? Then you're going to have to run over there, swap it. That's how data center works. This is great for data center. Okay. All right. Any question? And in the next part of our notes, it talks about logging. This is where we live as well, right? So your logs contain all the incidents, the events that the system has experienced, right? When it hits logs, it's already been done. Understand? Now, notification is different than logs, is that the alarm system sends off some kind of signal that it blocked or whatever. But incidents, a lot of the times it's all reactive. So by the time that you check the log, it's been done. Events happen, incidents occurred, okay? So when people tell me, oh, I'm looking at the logs, well, basically just seeing what had happened to that system, right? If the attack already happened, yes, it might be in the logs, but it already happened. So you're responding to an event that already occurred. So that means that we need to secure the logs, because the main goal of the attacker is to go in there, go stealthy, and not let you see. So they will delete log files. I don't need to go and individually delete the entry to the file. I just delete the whole file. And that's simple because most Linux servers store log files in a certain location, right? Windows does the same thing because we centralize that so we can find it. So that means that we need to protect it and back it up in case we need to investigate fraudulent incidents and things, right? So we need to store it in a certain area that's protected, and we need to monitor it. Why do we need to monitor it? Because you might have a log of an information or warning that might be important because your system is telling you that, yeah, I need help, right? Or your network needs help. Okay, simply that, right? Someone is attempting this. It's giving you some kind of warning. Okay, so sometimes companies will have log servers when they're large enough, like enterprises, and that will be part of your CM. And they would use a thing called Bastion host, and this is remote log server. So that way it will maintain the integrity, authenticity of the log. And this is where our analysts would work. So you will work directly with a lot of remote log server that's called Bastion host. So the role of the Bastion host in event logging is it's used as a remote log server. It's used for storing logs, but you would use it to monitor and analyze the infrastructure. Why do we say remote? Because you don't want to clump up all your system in one area, right? Logs are important in that it stores the details of the system in our infrastructure, your database, your authentication server, your certificate authority server, your key distribution center, all of those things, right, might be stored locally on those server, but you would extract those logs and then send it to a remote server so you can overall analyze, right, how everything is being serviced, how things are talking, in the case that if there's some issues with security across multiple systems, you would see it as a whole. And so for the CM, it manages the overall infrastructure, right? It would be stored there, and then you would have Bastion hosts for examining and analyzing. So as an analyst in security, you would operate here. Sometime, yeah, for investigation, a lot of the time we go to the system logs, we go to that actual individual system because the event might occur on that system. But if it's if you're doing forensic for the network, right, it's probably best to start on the outside, like these guys, the Bastion hosts, and then go and then dive into the individual system. Because in a network environment, if you're trying to see how many systems are impacted, best bet is the centralized log area. And then after that, you can go into the individual system, system 1, system 8, system 12, etc., and be able to pull their logs to validate. Any question? Okay, so for the next question, it asks you, how should we manage encryption and digital certificate in the infrastructure? As we learned that we need to use encryption for data and also other areas, even, web transport, right? We have to be secure with our encryption key, because taking the key is a lot easier than brute forcing the key. So capturing keys would be one of the goals for the attacker. So where your keys are stored, how it's shared is very important. So securing your encryption key and controlling decrypted data with permission and transit those data is important, right? So because we use key to decrypt the data, and once the data is decrypted, how are you storing it and who accesses it is essential. Because a lot of time people don't think about that. They were like, oh, I'll just use encryption, encrypt the data, but you use the key, so you have to secure the key. Sure, after you have the key, you decrypt the data, but how is the data stored and who accesses the data is important. Because sometimes I might not even need the key. I just need to find the system that has the decrypted data and who has access to it, right? So encryption is used on the network, on your hosts, which are could be server or endpoints, on data. Okay, so key transfer and storage, you need to securely design this. Okay, how keys are being exchanged. And then where your data is transferred, where it is encrypted and unencrypted. And when you use encryption, its partner is certificate. Digital certificate are just files, right, that is used to reference for the system on how keys are used, the type of permissions is used on the data or the components of that, an application, etc. So certificates are used to really refer to how keys are generated, when it's expired, or whether it's revoked. Key revocation, think of it like driver license revocation, simply that. Take away the keys. Though even if you had generate the key, once it's revoked, it's no longer valid. So that you also have to control, right? You have to manage the life cycle of the certificate. Web certificates, usually they have it not expired. If you ever visit a website and it tells you this certificate is, you cannot use the certificate for this particular website, you have to renew the certificate, right? Basically, they put an expiration on it. Little that they do that nowadays, but you might see some of the website that do that for HTTPS. Okay. So we would have an entity called Certificate Authority, your CA. This is a centralized area where it would control where we can create certificate. We can, distribute certificate. And in the case that if the keys is compromised, you need to check your root CA, your certificate authority, because that's where they go to get your keys. So certificates, right, is a reference file for keys. So why go to the keys where I can go to the authority of that certificate, right? The root CA. Okay, so that's the second part. We need to centralize CA to reduce the problems in responding to compromised key. And then if the case that if your keys are compromised, you need to change your vendor root CA. CA stands for Certificate Authority. So reconfigure the certificate authority or the root authority. And then we can manage the life cycle of the certificate to prevent expired certificate, because dead or expired certificate are no longer valid for key issues. So we want to make sure that we check. And sometimes you would have expiration on certificate for a time period, right? You don't want that certificate to exist forever. So yeah, you would put an expiration on it. And then in other cases, you might have a certificate that never expires. Many web administrator, they prefer unexpired certificates, right? But it really is the intention for that web usage. So you have to ask yourself, what am I using the certificate for, or am I using the certificate for, right?
example of when you would be
IoT. Like Internet of Things, sometimes it doesn't need like forever certificate, right? Or you know, your simply your application on your smartphone. Because in the case where sometime we want to put an expiration on it for upgrade and maintenance purposes, I might put it for 2 years, and by the time the 2 years is up, I have a new version of that app, and that new version would require maybe better security. So I want to renew that certificate, or sometimes less security, because sometime in the case, or if you want your app to be more flexible, right, you might turn on hardware devices, right, like microphones instead of just camera. And you guys see this, where it requires that you run the update, and with that you download the new certificate, and that new certificate tells you that you have to enable, you have to allow this for this to work, or GPS for it to work, or whatever, right? So active defense for improvement of security posture is a reactive approach, right? This has already happened to us. We want to fix what had happened to us. Okay. So how can we improve? We can control the damage in an attack as it is happening by countering adversaries. You rarely see this. They have to have a really good security team to do this. Sometimes that can cause more damage. So normally you would control the damage by stopping it from increasing. Just like how when a fire break out, you would use fire extinguisher to stop that fire from spreading, right? Malware, you do that, right? You disconnect the system and stop it from spreading. When an attack happens, you disconnect the system from stopping it from spreading. You rarely see, in the case of Caesar Palace, I think they did hire a contractor to, mostly not just to counter attack, but to find out more about the attack nature, so that way they can have more answers on how to potentially fix their problem in the long run. So yeah, in some cases, but that usually requires a lot of resources, right? The human resource, that means the effort, that the time that you put into it, the knowledge, right, for the human resource. So those people need to be an expert. Second, you need to have, the money to pay for additional systems, additional services, and all of that. Okay. And then that's going to help you perform threat intelligence. So the active defense is giving you more understanding of what type of threats that you're dealing with, or potential threats that you're facing. Hunting and countermeasures. So threat hunting is, this area belongs to a lot of the high-level analysts in security. So threat hunting, you researching it, you are following the threat, you potentially want to stop the threat from impacting your organization. So sometimes we will have countermeasures, sometimes we don't, right? We just reduce it or accept it. And then you have to do continuous evaluation and adjusting control based on organization needs. So this comes back to the question that all students ask me when they enter the program. Will cybersecurity job be abundant, right? Is it a good field to get into? Sure, it is, because of this particular line, continuous evaluation and adjusting control. That requires a lot, right? So you already saw the type of control at the beginning, right? You already saw the type of things that we need to reconfigure and all of those things, right, throughout the overall questions. And then the evaluation, and it's always evolving in how and what is impacting us, right? So it's really depends on you, right? The areas that you're going to get into, how motivated you are to get into the field, and so you have to evolve with it. Okay, So next we're gonna talk about honeypots. I touched a little bit on this in my 27 last time too. Honeypot is a way that we can better understand who is attacking us and what kind of attack is being used. But you have to come ready when you use honeypot, meaning that you have to be ready for, you have to set it up in a certain way where it doesn't impact your private network and systems and operation. It is an isolated area to lower the attack, but you want to mimic your real environment so that way the attacker will fall for it. So to capture attack traffic, you would use technique and tools to implement appropriate solution and countermeasures. So let's say that I want to set up a fake DMZ and put a honeypot there to really see if they're attacking my web server, my database, my mail server, and so on. Right? And then you hear honey nets, where honey nets are multiple honeypots combined. So in a large enterprise, they might have honey net. So the bears is gonna come for the honey, right? So we want insights, right? And methodologies. And some of that will go back to logs, evaluating logs, right? Evaluating activities on the network. And then going back to fix some of the problem we might be facing. And virtual environment is best for honeypot because you can control the majority of it. It just depends on how you configure it and how you network it. I think we talked about a lot of this last time. SaaS, software as a service, right? So make sure that when you are using or modifying security configuration using honeypot and so on, even on the cloud infrastructure, make sure you check with your vendor, right? You rent space doesn't mean that you can put anything on it. It's not like storage. Even with storage, they'll tell you, right? Like when you rent a room to put your things in it, things that you don't use for now or even using, right? You gotta make sure that you check the policy. But for the service, make sure that you look at the obligations on what you need to do for security. So access management and identity, definitely for SaaS and PaaS. IaaS, you need to configure OS for security needs, and you need to manage your system and patching. You can't just let it go. And then for the broker, for the cloud access security broker, you need to enforce policy for cloud resources and services and use. So if you're using virtual environment on the cloud, you got to make sure you enforce policy for that. And then your private cloud, your VPC, this is on demand and it should be semi-isolated. There's a whole course on cloud security, so a certification on it, as a matter of fact, right? And then you implement private subnet for securing information. So for assessing cloud, you can use audit tools that are third party. And then I put some information here for you. You need to do type 1 and type 2 report if you use SSAE. And there are assessment, like you can go to sharedassessment.org. They have some management tool. And then sometime cloud company with the cloud service like AWS or Azure, they do have incorporated tools. So we talked about honeypots already. For 12, how should cloud access security broker be used? I should say be used, sorry. I have a grammar error here. Be used or is used, should be used in infrastructure security. You would enforce policies when cloud resource and services are used. And that is very generalized, right? You have to know what type of services, which resources using that service, going back to what we talked about, inventory and auditing. Now, for preventative and detective and correction control, those are different. Detection is to identify or see. Preventative is like, think of it like to block or deny. And correct is to fix. There are three different things. People like to clump them up together. So preventative control would be firewall, because the firewall is good about allowing and denying, to block or to allow. We can also train people on the administrative area because, right, by training and retraining, people would have more knowledge and skills to have security practices. So that would give us preventative measure. Detective, we already said. IDS, intrusion detection system. Alarm system, like actual alarm system that sounds off when someone breaks into the building. That could also include video camera or surveillance system. And then for correct, let me move this down so you can see. Oops. For corrective control, we can have anti-malware application. Anti-malware doesn't really correct, right? What does it do? It contains, okay? Or when you patch, that's a corrective control. When you do updates or patch software. Almost there. So this list will go on for a long time, right? A layered security approach can be many things. Start with access, strong authentication methods, multi-factor, something you have, something you know, something you are. Then we would filter, block, or didn't allow, right? We can do host-based firewall. We can also use security software like host-based prevention system, HIPS. We can do data loss prevention. So what do we do for data loss prevention? Anyone know? How can I prevent data loss? Yeah, back it up to the cloud, to the server, storage server. But that's can also mean that, you know, so backing it up is just having an additional copy of it. But true data loss prevention starts with what? Permission control. Who access your data? Encryption. So data loss prevention encompasses a few things. Whitelisting and blacklisting, that, you know, that comes back to allow or deny. So we can whitelisting systems based on MAC addresses. We can also blacklist systems based on MAC addresses. We can also whitelist and blacklist URL to make sure that our users are not visiting bad websites or malicious websites. Anti-malware, antivirus software. But that, remember what I said, the chances of getting malware using AV is what? 50%, right? So some people don't use it, they take a risk. Because definitions are about 50%. The wild has 50% newer, right? Patch management, vulnerability assessment. So this is where most of you operate as an analyst. Vulnerability assessment. So for the ethical hackers, the pen tester, big area right here. System hardening, that entails a lot of different things, right? Comes back to patching, come back to using a lot of the security tools, common practices, configuration management. So I mentioned permissions and encryption already. So if you want, you can categorize them under certain things, but this can also be web encryption, right? Permissions for shared resources or, ownership of resources. Monitoring file integrity. So that means what? Hash verification, right? Logging of events, but logging is no good if you don't read the logs. So logging and monitoring events. Physical access control. We didn't really include a lot of the network stuff on there, right? Like segmentation, lots of things that you can do on the network. Using proxy, many things. So even if you have all the things on the menu for your security solutions, right? Sometimes we waiver one to have other area working. So, this is why we have no perfect solution. And you have to really look at, what's needed for operation, what kind of network or systems are being used. So there's factor that you have to consider. But defense in depth means all areas for layered security. So coming back to the controls, right? Where did I pull all that information from? From here. From here, right? Right here. If you wanted to grab that from the notes, it's there. So for policy, process, and standard, policies are rules, process are what? Steps to achieve the rules or follow the rules, and standards are what? What do you think standards are? What are recommended, right? Recommendation of practice. So standards are usually set by the industry. So let's say that, just to be up to the standards of this, right? Like I would do it this way. It doesn't mean that you have to do it that way. No, right? It's not regulated. It's just, you following the guidelines to make sure that you meet at least the base requirement or the base practices for certain things. Okay. So the design includes, these are the things. So you need to have a checklist: change control, configuration management, monitoring responses policy, entailing that could be many things, right? Personnel security control, business continuity control, disaster recovery control, and HR control. So for 15, in analyzing the infrastructure, identify the appropriate view based on given activities. Examine the occurrences for incidents and events based on the current or historical data. This is often done in logs. That is operational view, because it is incidents and events that happens in operation on the current premises, and also historical data. It already occurred, right? That is your operational view. When you're looking at your network diagram to look at your network design and weaknesses in your network, right? So for example, I have no firewall on my DMZ, and I'm looking at the diagram, the topology shows that there's no firewall, right? That is a logical view. And then when you look at system configurations like Active Directory for authentication in Windows Server, or firewall settings on port settings, block or allow, right? That's technical view. We're almost done. I'll give you a little break after this. So where can I find this information? Right here on page 6 of 7. For when you review the infrastructure, the common issues you need to focus on: single point failure and fail redundancy. Even if you have backup, you got to test your backup, right? Like I harp about that 5,000 times, right? Having backup is no good if your backup doesn't run when you need it. That's just a waste of time and space, okay? That means storage. And then you need to validate, check your encryption, validate your data integrity, check your hash, and then do data checking at the boundary, looking at the attributes. So here are the human errors. This is a big factor. Okay, so to limit human errors, answering the next question. Oops, sorry, some of you might be recording the last one still. Let me move this up. We would automate monitoring, because if you rely on a certain person, right, they might be sick and they're not feeling well that day, or they might not focus on the task at hand, and they might make a mistake because they might overlook something. So if you automate monitoring, because the computer is going to tell you what you instruct it to do, right? It's going to give you what you want. And we would set up alerts to detect human error. So we use the system to monitor the human. Might not go well in some organization, right? But I really feel that the automation process, if you test it before you implement it well, it can be seamless. And in many tech companies now, automation is a big key role, right? You know that with that, we see a lot of presence of AI. We can also constrain interface to allow only permitted activity. If you ever use Coinstar, you have constrained interface. If you use an ATM machine, you have constrained interface, because all of those are computing system, whether they're embedded or regular computing system, right? Like Windows in the back, but they only have that interface app to tell you to deposit coin, to print out your receipt, and that's it. Or to contact customer support because the machine might be down or whatever, but they can automate all of that too. Whenever the system is down, when it generates the error, it notifies their central office, and they would dispatch a technician to come down and fix it. I did some of that, right? So with that, you only have a few buttons for them to tap. You use Redbox, it's a constrained interface. So with that, you limit the user from making additional error, right? The more things you present to them, if they don't know how to use it, if it's a difficult app to use, likely that they're going to make errors. We can implement procedural check for separation of duties. So you don't give someone tasks in different areas that can lead to fraudulent activities. For example, right? Payroll and account payable don't mix, right? Because someone can send themselves paycheck. Account payable means that it's an area of finance department that pays vendor, right? Like if I need to pay my bill, I need to pay gas bill for the building, I need to pay electric bill for the building. That's account payable, right? But if you mix payroll with account payable, the people who issue the check, they mail themselves a check. So. So you need to have separation of duties and personnel procedures, and that's so HR, like background check, drug tests, things like that. Training awareness program requirement to prepare staff for threat detection. So you just gotta make sure that people know what a threat is, how they can see it, identify it. Could be people. So behavior, activities, right? And for technical threats, you need to show them what it looks like. Or how, even with like phishing, things like that, you have to show them what it looks like. And we can use an automated system for education purposes nowadays. But you can also hold live training, make it accessible. And then activities for infrastructure security maintenance. Schedule reviews. With that, we can follow up with an audit. By regulation, at least once a year. We have to have a continual improvement process. So after that, we would say, oh, yeah. So we would schedule it every 3 months, right? And then after each 3 months, you would take a week to kind of say, what can we improve in this such and such area that we found to have issues? So CIP. If you retire policy or processes that's no longer relevant, we need to make sure that we look at the impact of the processes and policy on our systems, right? So when you do away with the rules, how is that impacting our systems, network, people? And then we need to document it because, sometimes they live again. Or, when you find that it has impact and you didn't detect that earlier, you need to fix the problem by reference. But documentation also serves in that, for the next technician, the next analyst, the next group of people that follows you, or when you train someone, it's definitely useful. Okay. We document everything we do. Any question? Okay, we're finished. Let's take a break for restroom because they do lock it like later on around 8:30. It's still light outside because we had daylight saving. I'm gonna stop recording.